Technology. All right. Oh, so and this is a good time to ask, and Darren had a chance to think about any questions from the previous time. It wasn't really sort of thing that there's really nothing you have to remember about this at all. So I didn't really expect too many questions. And also I have to say that I don't necessarily expect questions about this, the next part, because it's more like inspirational things. Future things, I'm going to force you to ask me questions. I'll probably just stop on you make up a question, this sort of thing. But in this case, no, we won't do this. All right, so getting on for programming is hard. Now, why is programming hard? It's incredibly hard. And here is a statistic that proves it. So, of all of the projects started by Fortune 500 companies, like big companies, of all of them, more than half, it's actually more than half, don't even complete. But then Google, some people are supposed to be good at this. Goldman Sachs, So more than half of them don't complete. Okay, well, that's not so bad. But no, of the half that complete, half of those, more than half of those don't actually work. They do something, but they don't actually do the thing they were designed to do. And even worse than that, half of those aren't actually useful. They don't actually ever get actually put into service. So we're getting to about 10% of the projects that started actually end up going into service and being used. So why is this? I mean, they say, oh, you go, my joke. If builders worked this way, you'd be afraid to walk the streets because buildings would be falling on your head all the time. Imagine a world where architects failed to complete buildings most of the time. It would be appalling. So why is this? Well, why is programming hard? Well, is it intrinsically hard? Well, it's not that intrinsically hard. All of the steps are pretty easy, and plus you have this tremendous, what they call plasticity, malleability. You can just change it at will. Voila, I make a big change, and all this sort of thing. So actually, the individual steps of programming are hard. Is it that the field is not yet mature? Well, that's a lot of it. Like, people have been building bridges for thousands of years. They have technologies now. They know how to work. They've had numerous bridge failures, so they've got a chance to learn from those numerous structural failures. Every time a building or a bridge falls down, except for maybe World Trade Center 7, they figure out what the problem was and fix it up. So actually the problem with computer programming is it is too easy. It is too easy to do these things. And you're like, how can that be? Well, look at the hardware. We looked at all these chips. Once you've made a chip, that's it. You're stuck. It has to be right. So in order to get those, and there is actually no famous cases where people got chips a little bit wrong, and it's like there's going to be $1 billion mistake if you get that wrong because you've made it in silicon. It's permanent. So in order to avoid the horrors of this happening, they have to get it right. So they componentize everything. They make these things in strict components. They have strict descriptions of what's going on, which they do not change under any circumstances, because they know if they change it, that they will break everybody else. Computer programming is too easy. It lets you say, oh, we'll set this now, we'll do this, we'll fix it later, we'll do this, we'll fix it later. And as a result, you just get, Microsoft Word, you get all of these terrible, terrible things. Pick your favorite, Internet Explorer. I hate to beat on Microsoft. There are numerous other, I have lists of debacles which I'm just not even going to go through. So it's too easy. They ask you to do too many things. Once they realize you've done the base things, they get you to go on. They don't test. So we're kind of a victim of our own success in this thing. So what I'm going to do is teach you ways to make programming more difficult, but make more like overall fewer problems for you, more systematic, more relaxed here. So basically, there's a right now. There's a joke. Right now, you're in a kind of this difficult spot where nobody knows what's expected of you. See back to previously, not a mature field, and people see these amazing things happening. So everybody's tendency is to rush forward. You need to cultivate a certain zen. It has to be right in the right spot though, because if you spend too much time polishing, which is my problem a lot of the time, you never get anywhere. So you have to be balanced. You have to take a middle way. I should have called it really the middle way, but I wanted to use the Zen Buddhist joke as much as the regular. You have to cultivate a middle way between where you're doing things systematically. You're not darting off in all directions, despite what everybody's trying to force you to do here. And so I'm going to get into specifics about how to avoid getting tangled in your own feet in this sort of thing, because it's literally, I've been doing this for years, and it's probably been 5 or 6 years since I actually burst into tears in front of a computer. But I'm not the only person to burst into tears when the computer, when you've been working on something and you realize you have no idea what's wrong. People have actually taken off and shot their computers. A guy in a Texas sheriff's office shot the computer when it kept printing out arrest records endlessly and couldn't stop it. Oh, and I have a note here also that there's a key thing to Zen, which we'll get from again, and there's this great acronym YAGNI. YAGNI, which I probably should have put on the slide, but I didn't. It means you ain't gonna need it. And what that means is don't do work you don't need. Do everything very systematically. I'll return this again later. So this is all the meat for all of these things, and we're going to go through these in detail, one at a time. So we have, not enough time, be careful with your language. Language is magic. Control the state, which I mean the state of your program, not the state of the state. Disallow magic and embrace science. You'll see this coming up. Get it right the first time, if you can. That one's hard. Simplicity. Workflow, like actually making your work smooth, tends to be a big deal. Study the masters, something I did not realize when I was young. Until I got a chance to do it, it changed my life. Memorize nothing. Use a notebook. Use source control. I'll explain what this is later, but it's a way to keep track of what you're doing and clean up after yourself. All right, so here we go. So allow enough time. This is one of those things that is just appalling in the computer science industry, but people's estimates are appallingly bad about how much time. When they wrote, I skipped the whole thing early on the creation of Fortran and early language, this famous guy, not Jim Backus, that's the actor, Backus anyway. Famous computer scientist, he was asked to estimate how long it would take to write a Fortran compiler, and he said, oh, it's going to take us 6 months. And so 6 years later, they had the first Fortran compiler. 6 years, we're doing something great, people. So then they had to make a small change to the Fortran compiler. I mean, a pretty big change, but still, they had already written it, they decided to make a change. So he looked at how badly he was wrong the previous time, and he's like, okay, I was clearly very much off, but it's only a tiny change, so I'm going to estimate 18 months. And 6 years later, they had the second version. So he didn't, and the trouble is, again, it seems like it's over. You can see your way through. There are unexplained things will happen. You must, I cannot emphasize this too much, double or triple your estimates and give yourself so much time it seems ridiculous. Trust me, if you're at the end and you have an extra day or two to do whatever it is, you won't complain you got it done early, and it will literally save you weeping in the middle of the night. So you've got to allow far more time than you expect. You can't think properly when you're panicking. You will make mistakes, and making mistakes in computer programming takes far more time to fix than it does to not put them in the first place. Far more time. Worse, the further you go in a program, the harder it is to fix mistakes. In fact, mistakes, every step away from the initials, you writing a program, going out, ending up to some guy sitting at his desk gets a problem. Every step away makes it 10 times harder to fix the bug. So a bug that gets out to some guy in the field may be 1,000 times harder to fix than a bug that you just created a few seconds ago. So take your time, and desperation is just miserable. Oh, you hate it all. So just always allow far more time. I'm going to keep coming back to each of these things and saying, look, here, you won't be able to do this if you don't have enough time. So if there's one thing you do, pick enough time for this thing. Now be careful with your language. There's a famous anecdote here, which I discovered was not true. They sent a spaceship to Venus. So goes the story. They sent a spaceship to Venus, the Mariner, U.S. Mariner, and it did not make it. Why? It turns out that the language you're using, Fortran, made variables that started with IJKLMN with integer, whole number variables, and they had done a calculation that had a fractional part and assigned it to an IJKLMN variable, throwing away the fraction. Net result, spaceship does not get to Venus, millions of dollars and 50 man-years of life. I've heard about this my whole childhood. It's not true. It turns out it's not true. But such problems happen all the time, and there's an actually really bad one along these lines. The Columbia spaceship in PowerPoint. Basically they had this beautiful thing where they had unfortunately defined away all the cases involving very cold, they had just all put them in one bucket, tiny cold to very, very cold. If they had correctly named and identified these things as separate cases instead of just throwing all this stuff they didn't care about in one bucket, they would have seen that all of their failures in this one thing, instead of being these very occasional failures, were all completely concentrated in this tiny area where things were extremely cold. And they could have realized that in fact is the cold was the sort of thing, was the thing that actually made the O-ring that kept the two parts together shatter and caused Columbia to explode, killing everybody. And a later analysis actually attributed it to excessive use of PowerPoint. That they tried to fit too much information on one slide. Oh no, that's the place. They had a limit to the information they fit on one slide, so they had to basically glue things into pretty big boxes, and one of those boxes contained all the danger points, and they're all just hidden off there. An anecdote about this, Richard Feynman, everyone should read his autobiography. It's the funniest thing in the world, and also teaches you how a Nobel Prize winner thinks. But he was on the Challenger Commission. Actually, he was on the I guess the Columbia Commission, and everybody else gave their own talks, and he actually gave a completely separate talk. He had a separate report because they wouldn't actually stamp off on his report. It was so incredibly rude. And when it came time for the press conference, everybody else gave these long, meandering talks, blah, blah, blah. At the beginning of the press conference, he had a piece of O-ring. He showed it to everybody without saying a word, and he put it in his glass of ice water. And then when it came time for him to talk, he pulled it out and smashed it on the edge of his desk. Didn't say a word. Got the point across very, very well. So people die when you get your words wrong. So it's really important to learn the correct words and to use the words that everybody else is using. When I first started in computer programming, when I got my first real engineering job, I kept mixing up memory and storage. I got yelled at by my boss. At the time I thought, why did I mention? He was totally right. I realized later on, so get the words right. All throughout this course I'll be very specific on words, encouraging you to use the right words. Do the research, see what other people are doing. Just absolutely key. Now, control of the state. Well, what's going on here? You've got some computer programming, you're trying to do things. Well, you have this big nebulous state where you have, what this is you've got variables, things you're manipulating, maybe they're drawings, maybe they're text. Well, what they all are, and this is where that pointer, oh, right here it is. This is where the pointer will come in handy. You have some name, N, and some value, 17. Here we have some name, message, some value, what's up, dog. Right? So, everything your program is doing before it comes to the final output of printing your poem, doing your piece of music, showing your drawing, is manipulating variables in this state, named variables, changing them. The only source of true bugs is not understanding the state. It's losing track of the state. So you have to have an extremely clear idea at all times. And if you don't know what's going on, you are going to, with the state, you're going to get lost. It's very, very important. And again, I'm going to be teaching you techniques to do things like say, I'm expecting the state to be this, and if it isn't, I'm going to die. You're like, oh, I don't want my program to die. No, you do want the program to die. You want it to die early on, the moment something's wrong. You put those things in, and it's like an burglar alarm. That's what I'm looking for. It's like a burglar alarm that goes off really early. You want that burglar going off the moment you get to the point you don't understand anything. You can often see good programs, they litter their code with such statements called assertions. That's exactly what you'd say. I assert that N is 17. I am asserting this. And if that assertion is wrong, it explodes immediately. You want this sort of thing. And the reason is, of course, your state becomes, after a while, just terrific and impossible to understand. And if you don't have those, and the things that you understood yesterday, you will not understand today. So you have to keep control of this. It's, again, like all of these things, cannot be overemphasized. All of your mysteries will involve the state, the actual state of the machine is not what you believe it is. I don't want to belabor that one. Disallow magic. Now, have any of you heard of the cargo cults? There we go. So cargo cults was this amazing thing. Basically, in the Second World War, the U.S. Army went out to a bunch of South Sea islands and set up military bases. And since these were pretty liberal cultures, you didn't mind if the GIs fool around with the young ladies and things. Very, very basically characterized by good relations, amicability, and these people love Coca-Cola. It was a big deal for them, I should add. So at the end of the war, the US military said, well, thanks a lot. Left all the Coca-Cola. Seriously, cases of Coca-Cola for these guys. Probably very bad for the teeth, but whatever. And then split. Well, these people were appalled. They believed, reasonably rationally, that the US military was gods. I mean, they'd flown in, they did all these amazing things, and they thought they'd done something to upset the gods. So what they did is they said, okay, we're going to build the things that the gods built, and that will bring them back. So they built things like airplanes out of bamboo. Now, unfortunately, I couldn't find, I have a magazine that has pictures of this. I couldn't find pictures of the inside of the cockpit. These people clearly had very good visual memories. They made a very accurate cockpit of bamboo with like bamboo instruments and this sort of thing and things like, I did find this, that's a bamboo headset that they made with a bit of bits of old used metal and this sort of thing that's like a headset that they were. This will never fly. You will never be able to hear sound on this. It looks a lot like the real thing, but it isn't. And it's called cargo programming, and you should never do this. The trouble is, it's extremely, if there's one tip you get from this thing, it's actually to avoid that. If there's one thing that separates people who are upset and clueless from people who aren't, is absolutely eschewing magic. You will see this all the time. People copy other people's code into their own code and just use it without understanding it. And you go and you say, well, what's this there? And they're like, I don't know. It was there. I put it in. That's bad. I can't, you're like, you won't be able to get mastery over what you're doing. The problems will lie in that section of the code you do not understand. So you cannot accept magic. You have to, and this is when we go back to, well, in fact, it's on the next slide here, is science. And in order to do science, you have to take the time, particularly early on. I've tutored a lot of people, and people get this thing where I say we have to systematically work through this. No, tell me the answer. I'm like, no, you have to work it out. And sometimes early on when using a program, you have to stop and spend 20 minutes to figure out exactly how one specific tiny thing works. Take that time. Don't just say, okay, I have some idea, it's working. Because, okay, it seems like wasted time now, but later on you will just know. I don't know, the X-Men movie is a very interesting example of this. You know, they keep, Metallo is kept in a thing where he has this structure of metal that he just builds out through the air with his mind. That wouldn't really work, and the reason is that he can't, he would take infinite force, in fact, to keep each bit of the metal level. So if you were gluing them together a bit at a time, each one would sag a little bit. So if he started walking on the thing, it wouldn't take very long until he fell off the bottom, because he can't make those things 100%. But you can. If you are actually scientific about what you can make each step completely solid. If your program is to be, not to be like, another example is Meccano. You've all used Meccano or something, right? Where you screw things together. If you don't screw together your things really hard, the whole structure will become loose. So, as I said, if you get one thing from this whole part of the talk is, do not allow magic into your life. If something is mysterious to you, unless you're in a desperate time pressure, but again, you won't be because you listened to my first thing and took enough time at the beginning. Even if it's not your direct thing, you should stop and figure out, why is this doing the magical thing? What is going on here? And you do it with experiments until you understand. You do it by writing in your notebook. The worst case, you write in your notebook and ask somebody or post on the internet. We have all of these things that you can't allow magic. Everybody has a little bit of magic in their programming life, but more than a little, and everything will be rickety, and you will feel unsure and stressed out, and you will yell at your neighbor, and it won't be any fun. So just eschew magic, embrace science. Is there anything else on this one? No. Oh, that's right. Big deal here is, at the beginning, it will make you slow. You'll be like, I can't believe I spent half an hour figuring out how to add numbers or whatever it is. But at the end, you will be able to fly like the wind because you know each step. You're not approximate, you have it 100%. So, again, if there's one part you remember for this, eschew magic, embrace science. All right, so this one is, I threw this in, I'm kind of regretting it in some ways. If you can get it right at the beginning, it just saves you so much time. It's worth it to manicure your code. It's worth it. It's much harder to fix bugs in the right code. It's much, much, much harder. So it's worth it. These days, I'm I'm a really good debugger. People call me up to fix their bugs. I hate it. I don't know how long it's going to take me. Sometimes it's terrible. I literally now, I write my code and I read it all the way through, all over again from the beginning, just to see what's there. I will actually rearrange it while I'm doing that, because I'm like, I don't understand what I just did. It seems, again, when people watch me, like, well, you tried it, it worked, and now while you're going back and rearranging it, I don't fully understand it. It has to work 100%. That's why I want to try and get it right the first time. This actually happens. I've been doing this after a mere 20 years of doing this. I actually started with some regularity to get things to work the first time. So 20 years from here is uncertainty is demoralizing. You should take your time, as I said. And this point is, this is a condition to be aspiring to. You're going to make a lot of mistakes doing this. What to say? But it's still worth, even in the early phases, to say, okay, stop. Let me look for this. Am I doing something stupid? Did I tie my shoelaces together? What about this? So, this is, as I said, a condition to be aspired to. But remember, I guess the takeaway point about this is, and I still do this and it's terrible, is you go through and you say, okay, I've got it mostly right for this stuff, I'll go back and fix this up later. Don't do that. Because you've given yourself enough time, get it all just completely solid before you do it, and then you will find that one day your program will work right the first time and you'll feel like a god. So there we go. So next, simplicity. I cannot emphasize how many times I see actually people who write terribly, terribly complicated code. I just did a programming competition with people, and they were actually really good. But in some cases I saw people went out of their way to generate extra complexity for themselves. I hope I have the phrase Yagni here. Do I have it? Simpler is always better, of course. And debugging is twice as hard. Oh, sorry. I should say, debugging, a famous thing that this very charming old guy, Brian Kernighan, said. He said, debugging is twice as hard as writing programs. So if you write a program that's the limit of your intelligence, then it's too difficult for you to debug. You'd have to be twice as smart to debug it. So you should always write programs that could be understood by somebody half as smart as you are. And it's a big deal for this sort of thing. There's, did I put Yagni in here? I really want to put that in there. Oh well, I did not. Young programmers, this is a big deal here. I'm getting ahead of myself. Young programmers looking for trouble. This happens all the time. I see people who are young and aggressive. There's this new feature. I want to use it. And what they do, they just shoot themselves in the foot where there's no need. You should, I can't believe I did not put Yagni in there, and that stands for you ain't gonna need it. What that means is you shouldn't do anything in writing a program until you are forced to do so, right? And you know, you're like, oh, I'm gonna need this in the future, so I'll do it now. Terrible idea. I used to do this, actually, this was taught, the idea of designing for generality was taught to me in university many years ago. Nobody does this anymore. It was a bad idea. It turns out that you ain't going to need it. You probably won't get to that phase. Or when you do, more often than not, the thing you have built is not what you actually needed. You didn't figure out you didn't know what you were going to need. You guessed, and now you've hit that point, and it's not what you needed. So simplicity, this whole thing of simplicity will get you to that point where you say, okay, I'm only going to do the simplest job, so I'm not going to design for anything I don't see. This is now called extreme programming. Terrible, terrible name. It should be called conservative programming, fuddy-duddy programming, boring programming, even better. Let me tell you, programming is actually a lot of fun, but some of the excitement is like fear and grief and horror. You want to avoid that sort of excitement. That's why I'd like to call it boring programming. And I want to make another thing, particularly from this contest, this competition is, sometimes people say, okay, I have this simple thing that I do and it works. Now I'm going to repeat it 37 times. And that's also simple. It's the simplest way. No. Verbosity is not simplicity. If you see yourself repeating something over and over again, you should strive to find a way to avoid doing that. I will be teaching you techniques to do this. And again, it's a fine line. Often you see people, they do something twice. And then they say, okay, I've got to work to avoid doing something twice. But then their way of saving that time doing it twice is much bigger than it would be just to copy and paste it once. But the key thing here is cut and paste, where you just cut and paste things and make changes. It's a trap. Don't do it. It is not simple. You are saving simplicity in creating something, but you're spending simplicity in understanding that thing. And again, it's going to get you into trouble. Okay, so again, simplicity, simplicity. Do I have here? I do not. Now, workflow. That's a key thing here that I didn't appreciate when I was young, and it says, unfortunately, you can go off on two sides. When people are young, they don't pay attention to it. Then they get older, they get obsessed with it and waste a lot of time that way. Workflow is what you do in your day-to-day operations to actually, let me get a glass of water here. It's what you're actually doing to write the programs. And you find that there are a lot of repetitive actions that you're doing. Well, you should be striving to eliminate these. And it's not just because it speeds you up, although speeding things up can be very, very important. A classic example, for example, is testing. You should be testing as often as you can. You should be making tiny steps and testing them after each step. If you have to test everything by hand, you will go crazy and you will not make these tests. That's why we have these things, which I will teach somewhat later, called unit tests, automated tests. I have my unit test attached to a key. So I sit there, and the moment I just finish something, I just press that key and see if the tests run. I can literally do that when I do that. Literally, if I have a cup of coffee in front of me, I will go press the test and drink the coffee and see if it runs. And it makes a big difference. It means that I run the tests all the time. So it's very important to get workflow, and it's not just to save time for yourself. It improves correctness of your code. If you are doing something automatically, you will never get it wrong. If you're cutting and pasting and then making changes, if you do 30 of those, you will make a mistake. So streamlining your workflow and automating out all the stupid tasks is a great way to go. Now, also, when you get things like this where you have to do something minus, it breaks your concentration. There's been so many studies these days about how to work, and one of the classic things is every interruption of your actual thought is basically 10 minutes lost, no matter how tiny. So 10 minutes lost. So that means if you are interrupted 6 times an hour to do something, you basically lost that whole hour. So you want to minimize interruptions, and self-interruptions by having to do some dumb task that doesn't really require your intelligence, requires attention, it kills you. So that's another reason to do this. However, and that's my thing. You could have done this 5 minutes lots of days, 2 days a year, 4 days a year. And also, there are many 5-minute things. I streamline my thing, and then I can actually just, once I've spent a couple of days streamlining, I can just whip through things, and then you get this tremendous sense of mastery. It's very good for you. However, there is something, you can't go too far. You get on this thing where you start off this, and then you want to automate everything. You spend days automating something that takes you only do 2 or 3 times ever. So it's kind of a Schiller and Charybdis, these classical metaphors. You're between a rock and a hard place on this one. But you should spend some time when you start off something, spend some time. Optimize your workflow. Streamline your workflow so that you're not doing stupid repetitive tasks that use up your fingers and your hands and your back and your mind for no purpose at all. That's a big deal here. Study the masters. I can't tell you how much I learned. Particularly, you probably know I worked at Google for 5 years. I came to Google. Shit, I'm going to show these people. It was awful. It was really it was terrible. It was like boot camp. Everybody's really nice to it. One of the things they do is, especially this huge quantities of code to read, vast quantities, and then everybody reviews your code, which is, they go through it line by line and they tell you what's going on. Reading this code was an astonishment to me. Firstly, because I just learned a vast number of techniques. Secondly, I saw some of literally the greatest programmers in the world. I was shocked. Initially, I thought how unsophisticated their code was. I was kind of like, this is really disappointing. I expected it to be ultra fancy, and it's not. It's dead simple. I'm embarrassed because, in fact, is now when I look back at the code later, and there are these people, Jeff and Sanjay, this pair who've been coding together for like 10 to 12 years. Their resumes are just astonishing. I mean, they've achieved dozens of significant things, any one of which might be a person's entire life work. And yet you see their code, and it's extremely simple. It's short, and they use these clear names that aren't very complicated. It looks kind of almost childish. Until I actually started to see what the experts did, all my stuff was way trying to be clever and show off. Remember I said, hot young programmers looking to impress? Yes, that was me. Learning from the masters is the only way. There's a great number of things. And there's a large-scale thing that you also can only find by seeing the masters and by failing yourself. But building a large system and failing is miserable. Literally, you can be at that point where at 2 in the morning you realize, I've just spent 2 months on this and this will never work. So it's happened to me. Don't let it happen to you. And one way is to see how people who actually have done this successfully build large systems. And frankly, if you're building a large system, you should just find some famous large system and copy it. Honestly, once you get good, you can tweak it up. It's just much better to do this. Conversely, you should be looking at the tiny brush strokes. That was what I was going to my point, seeing these Google things. When I saw these guys' brush strokes, the tiny little things they did to do day-to-day chores, I was shocked with how dead simple everything was. But then I realized it's dead simple and you can completely understand it and get it right. That's why what made them the great programmers they are, that they went out of their way not to shoot themselves in the foot. So I learned a vast amount about this. Again, you can learn so much from the workflow of a great programmer. Watching these people work, you're like, they just don't do a lot of the stupid tasks that you have. They've figured out a way around it, or they've automated it out. Plus, people are usually very friendly. If you ask them, they will give you this stuff, saying you've like gone there so many hours. So, I had to put this joke here. I don't know if any of you are familiar with Garth Marenghi's Dark Place, which is a really stupid, funny fake horror documentary show, British show. And at one point Garth Marenghi says, I'm one of the few people who's written more books than he's read. And it's very funny, but most programmers do not read a lot of code. You should actually be reading computer code once you get to that point. It actually can be really, I'm speaking as a bit of a convert here, but it can be really interesting because if nothing else, you can see bad code and you can actually see bad code and scoff at it. It makes you feel really good. Oh, I could do better than that. And then you see good code, you learn it. So there's a classic statement in computer science. You say, code is written once and read 10 times. And that's very true. Actually, really good code is probably written once and read 100 times or 1,000 times. So if you're not reading, particularly in the early stages, 10 times as much code as you're reading, you should read more. Again, it's hard when you first start out. You have to experiment. You have to just charge forth. That's fine. But as you go, you want to read other people's code. And here we go. Memorize nothing. Don't memorize things. Life is too short. Memorization is boring. You don't want to do it. Memorization is risky. If you get it wrong, you're going to introduce this bug. And worst is, you won't even be able to read that and see that you did this because you believe in your head that it's the right thing. Don't memorize things. And in fact, this documentation changes. You memorize something 2 years from now, it's not true anymore. And then you get into trouble with that all the time. So you don't memorize anything at all. What do? You use the documentation. You look it up every time. You get really good at looking things up. The key idea is to just look everything up every time you do it. And what again, it's back to workflow, is you need a way to quickly go and to locate documentation for everything you do. To be able to look up the documentation on a moment's notice. Again, I have a keystroke where I press a button and I say, type in anything, I get the documentation. So again, I can't emphasize too much. There's another point, of course. Important things, you'll memorize anything because you keep using them. You won't be able to avoid it. So you'll end up memorizing the stuff that's important without even trying. If you don't, that's fine. Really good people look it up all the time. You're much better to get good at using documentation than you are to memorize. And so, in order to do this, you need to use a notebook. Now, I recommend a physical notebook when you're studying. I think you should just carry a notebook around like a lab notebook and just every time you do something, write it down. Every time you come into something, write down. A lot of people, personally, I do not practice what I preach. I have many notes digitally. I do not carry a physical notebook around because I just don't. But you know, and if you're the sort of person but I can't, again, it's one of those things that when I first got to Google, again, they just handed me a notebook. And it's like a lab notebook, literally, you know, one-sided pages. And you literally, so you have, I think of this as a notebook as your second brain here. And really, you should keep half of it blank. You have the right side is for notes, and then the left side is for correcting your notes later when you figure out what you did wrong. When you're learning, having this notebook will save your ass. You will go back to the number of times I've done something, I'm like, I did this 2 weeks ago and it took me an hour. What did I do? I cannot remember. You won't have these problems if you have a notebook. And That's part of how I got on this. So you use a notebook, an absolutely amazing thing. Oh, if you need to back it up, scan it. Or just do it digitally. So here we go. And we're down to the last thing, clean up after yourself. There's a concept of what's called technical debt. Technical debt is this terrible thing. You finish the project and you're like, okay, I'm done. Okay, off the beer. Nothing wrong with beer. The trouble with that is, there's all these things you didn't clean up, and they are going to be minefields for you as you go on. Right now, I'm helping hire people for a project where I was initially, they wanted to pay me significant sums of money to take this on, and I realized I did not have the mental space to deal with the vast amounts of technical debt that they had amassed in this thing. That it's literally at the point where just to get their program from your desktop to be deployed is like multiple, very obscure, difficult steps. And no one of those steps, the guy didn't set out to say, I'm going to make this difficult. He was just working at breakneck, and he never got a chance to clean up after himself. He induced what you call technical debt. Technical debt can be very bad. Even large companies have it. Yahoo has done better in the last few years, but they didn't produce anything new for like 2 or 3 years. And the reason is that they ended up in this tremendous technical debt where they actually had problems like, some of their programs have gotten so big that they couldn't put them together anymore. They were too big to be built because they just let all this crap cover the whole program. And at a certain point, it's like cleaning up it's very much like actually cleaning up your workspace if you are a carpenter or this sort of thing. Eventually, you're going to be at the point where you won't be able to find your soldering iron or whatever it is because it's covered with crap. And let me tell you, don't look at my desk, okay? It's bad. I have severe technical debt on my desk, but my code bases do not. I'm very careful on this. Also, cleaning up, I don't think I even have these points. Oh yes, walking with, it's like trying to program with technical, it's like hiking in molasses. The reason I couldn't do this job for this guy, I literally said, I do not have the mental space to do this. I actually got him to hire a young guy who really is hot and it's going to be his only project. He's much cheaper than I am too. So that worked out for everybody, I think. He's getting a lot more work from somebody who actually cares about this stuff. I just kept throwing up my head and saying I couldn't deal with it. But literally it won't be any fun. You have to do a bit of clean up. Okay, and beautiful code is just simply better. When you clean up, you find bugs, latent bugs. This happens to me all the time. I'll be going to do the cleanup afterwards. I'm like, oh shit, it would never have done this thing when I get to the cleanup. I'm like, oh, I forgot to put this part in. Terrible, embarrassing things. Don't let it happen to you. Clean up after yourself. And that's it. I said I'd keep the second half shorter than it is. I could ask any questions. This isn't necessarily something you can ask questions about. Let me tell you a little bit what we're going to do next week. Next week I'm going to actually show you the Python language, and we're going to go through Python like it's a desk calculator. Literally just to show you how to use it on a hands-on basis. And even as a desk calculator, it's just kick-ass. It's really easy. It does all these things you would want for free. And I'm going to introduce you to simple concepts, the state of the Python thing, all variable names, how to do very simple calculations, trivial programs and this sort of thing. Even if you've left after that first class, at the end you would say, okay, when you go down to literally add up things, you would say, I'll fire up Python, it'll do 2 seconds, and it'll be just much better than doing these things by hand. So that's going to be the end of the next lesson. By the end of the next lesson, you'll be able to use Python to do simple tasks involving calculations or, in this case, dealing with strings and numbers, eventually poetry and stuff. And you'll have some idea of how to put together even a simple Python program. And that's about it. Thanks a lot. Okay. So if you have any questions, I'm not quite sure there's much to ask questions about it. What are you going to say? Are you right? Okay, great. So we'll see. I hope to see you all next week, and thanks for coming.
I'll just put it on.